All right, so I'm Nick Gauthier. I'm the founder at MeetSpace. I'm going to be talking to you today about optimizing RTC for distributed teams. We're a very new company, only started back in March. And I just wanted to say a big thanks to Chad and WebRTC Hacks. It's an amazing resource if you're getting started to be able to go through all the stuff that he's written and use that when you're building a WebRTC application. So, MeetSpace's goal when we set out, we wanted to build video chat for distributed teams. And distributed teams are a little bit different in their use cases and what they need from a video conferencing tool. So they're individuals, and there are also offices involved with remote teams. So sometimes you've got people all in one office, but then different locations around the world are where a bunch of your other employees might be out of their house, out of a co-working space. And video chat might be the only way they really see each other. And also, they meet a lot because it's the only way that they see each other. So there's no hanging out around the water cooler. It's really just getting in touch on Hangouts, on Skype, and it can sometimes be difficult to keep those personal connections. So we're a firm believer in doing our homework. So before we even wrote a line of code, we did a bunch of research about what video conferencing features distributed teams were really frustrated with. So when we asked people what they wanted, I'm getting feedback off of. I'm moving farther from that mic. I don't know if it's helping. Yeah. So the number one thing people were frustrated with was dropping in and out of the call or having to restart the call or restart their router or restart their computer. After that was echo and feedback. And then after that, scratchy, low bitrate audio, the dreaded robot voice, delay in the line, causing people to interrupt each other because they can't tell when someone else is going to speak. And then you get to the negative side of the trade-off survey. These are things people think are not important. So they didn't think it was that important of a problem to solve that there are too many people talking at once. I guess they've never been on a meeting with some of my teams. And then what was really unimportant was pixelated or low-resolution video. And we found that was pretty interesting, too. So what that meant for us, the important features that we needed to solve, just a couple of really easy things we were going to do real quick. Not dropping anybody off of a call, no echo, having really clear audio, and very low delay. And then what turned out to be not important was video quality. So how often do you click that low quality setting in Hangouts or another tool just to get it to work for you, right? And then the downside of that is when you scale everything down to low to make it work, the audio ends up being low quality too. And that's a real downer. And like we saw from the survey that we conducted, audio quality was pretty important, that delay, quality, disconnections. So the question we were faced with was, how do we deliver the best audio? And for us, that was WebRTC and specifically the peer connection that allows peer-to-peer video and audio data between two people's machines without going through a central server. So, speaking of WebRTC hacks, I shamelessly stole these diagrams. They're awesome. On the left, what you have is what I'm talking about, that peer-to-peer mesh network, it's called, where there's a blue arrow there as well. Everybody is connected individually to everybody else. On the right, you have what's called a mixer setup, where everybody's computer is going through a central server, and that server is routing the traffic. Like on the right is what you have with like something like Google Hangouts. And on the left, you've got peer-to-peer connections that you find on things like, I believe Skype goes peer-to-peer, and I know a peer-in, if anyone's used that, goes peer-to-peer. And that's when I read this section of that article, and my heart sank a little bit. And it says, even if it looks like an inefficient solution, in practice, it's very effective and provides the lowest possible delay with independent, out-of-the-box bitrate adaptation for each receiver. Yes, that sounds great. The only problem is that this solution requires a lot of uplink bandwidth to send the media to all the destinations simultaneously, and existing browser implementations require a significant amount of CPU power to encode the video multiple times in parallel. So that low delay, that's great for us. We want that high quality audio getting between people really quick, but lots of bandwidth and CPU, that was going to be a problem. But there was that really awesome last section of our trade-off feature survey, which was that the distributed teams we surveyed didn't care about video quality. So we embarked on a series of experiments with a couple of companies who were testing in alpha and also doing our own tests internally to measure and figure out what was causing the CPU and bandwidth limitations on mesh network calls. And we figured out, and this seems pretty obvious, but it's nice to do your homework and test and make sure that your theories are correct. But the size of the frame of the video and the frame rate determine how much CPU you're going to need to encode that stream. So it's kind of like a pixels per second. And then this was easy, right? The bandwidth of the call is going to be determined by the bit rates of the video and audio streams up and down between each participant. So we embarked upon our quest for acceptable video. And what we determined, or what we decided acceptable would be, is if you could really easily and clearly determine somebody's facial expressions, their gestures, their emotions. If you can't really tell how somebody's feeling on the other side of the call, it's not really worth seeing them. You might as well just have an audio call. So we needed to preserve the emotion in the call. And for distributed teams, that emotion is really important to be able to connect with the people that you're not seeing. So what our settings ended up being, the frame size was 320 by 240. That's 240p. That's the setting that's usually below low and is called mobile or something else. For frame rate, 15 frames per second, and this is the one that really shocked me. We dropped the bit rate to 233 kilobits per second. That's lower than like an iTunes MP3 that you get, but this is for video. So this really surprised me that we were able to drop it down that far and still get something that was really working, or at least was adequate, where you could see how the other people were feeling, their facial expressions, and getting that all across. But I was pretty surprised at how much we could tighten the vice on WebRTC and still get something out the other side that looked pretty good. And then after that, we started testing this. And this is what people said. Without a doubt, the smoothest tool we've used. Reliable, doesn't tax my laptop. And then my personal favorite, is there a low setting? Somebody was worried that this was going to be a little too much for their Wi-Fi and wanted to know if they could turn it down if it got bad. So the smoothness, that comes from not fully utilizing your CPU and your bandwidth. Having a little headroom for when your neighbor starts streaming something, or when you open up Google Docs to share your screen, something like that. It spikes up your CPU, spikes up your bandwidth. But if there's a little bit of room there, then you're not going to stutter on the call. You're not going to lag on the audio or lag on the video. Reliable, same thing with the smoothness. Doesn't tax my laptop. Just keeping that CPU low, keeping the fan from kicking on was a huge help. Here's a picture. This is a couple of us meeting for our weekly meeting. You can see all of us there laughing at Brian's cat. You can even tell pretty clearly the facial expression on the cat. So the quality level, this is low, this is adequate, right? You can see what's going on. You can tell what's happening. I don't have a video or an animated GIF or anything like that. I don't have fancy slides like Chad. But this was definitely enough for us to have our meetings and be able to interact, meet with each other. So I'm going to get into a little bit of technical stuff. Not too technical, but these are the ways that you take some of the constraints that we discovered and apply them to your code. So first of all, we use the WebRTC adapter. This is a great adapter library that will load up in Firefox and in Chrome and give you a WebRTC interface that you can use, despite the fact that it's a working draft and that Chrome and Firefox are a moving target. For our get user media constraints, this was just the way that you say, for video, I want the width to be ideally 320 and height 240. Different cameras will have different frame sizes that they can capture, and by using the ideal, you can tell them to get as close as you can. Similarly, with the frame rate, we set a minimum of 1 but a max of 15, and doing that, the camera's going to do its best to max it out within that range. And we've had to fiddle with this a little bit as well. I think currently our max is like slightly higher just to make sure that all cameras can support it. For the audio, there were a bunch of these awesome Chrome things. So Google built a bunch of these features into Chrome specifically for Hangouts, but that doesn't mean that we can't use them. So I found all these awesome flags, probably on WebRTC Hacks or maybe one of the other WebRTC blogs out there. But having Chrome be able to do echo cancellation, gain control, noise suppression, and have a high pass filter was really great. That means that when everybody's got their mic on and unmuted, but they're not talking, they don't actually make any noise. That was the biggest one with, but also the echo cancellation in case people have got some speakers. Although really, you got to use headphones. It's just the best. All right, a little bit harder, constraining the bitrate. So to do this, you have to modify the SDP, which is something you might hear people talk about maybe in a sort of a mystical way. It's the document or the piece of information that's exchanged between peers to determine how they're going to communicate. And there is a spec that you can read through. There's a language. You can parse it. But what we're doing here is we're saying, when I'm creating an offer that's going to go to somebody else, before that offer goes, I'm going to run my special set media bitrates function on the SDP and get a new SDP and set it back. So I'm going to, inline, I'm going to hack it a little bit and then continue on. And then when that offer is sent to somebody else and they're ready to respond with their answer to complete the handshake, we're going to do the same thing and we're going to modify the SDP to clamp the bitrate on that side. So this set media bitrates function, in this case, what we're doing, and there was too much code that actually does all of the parsing. If you're interested in how to parse and hack an SDP, I'm going to be writing a blog post about that soon. The short story is, based on how the SDP spec describes, you find the M line for the stream that you want to modify, whether that's an M equals audio or M equals video line. You skip all of the I and C lines because those come before the B line. And so then you modify or add a B line that says AS233. In our case, that'll be 233 for our video bitrate or 100 for the audio. So there's libraries out there that you can get that will help you modify SDPs. We had to do so little that we just wrote a function to handle it for ourselves. But I thought I'd share that here. And like I said, if you're interested, I'll write something up about it, or you can bug me during the break. Okay, so now we know our bandwidth, 233 and 100 on the audio. That gives us 333 kilobits per second per person. And that's pretty crazy low, considering that the ceiling for audio for like MP3 AAC, they're going to cap out at about 320. So we're talking marginally higher per person than listening to Spotify. Actually, Spotify might be lower, but we'll go with it. This is Opus codec, 100 kilobits per second, 48 kilohertz, and stereo. Yep. So that was our high quality audio, is driving that audio bitrate here all the way up to 100. So there was one time where, during the alpha, I was talking with one of my advisors, and we were getting an echo. And I was pulling my hair out because this is my app, and I am not going to have an echo in my app. And we figure out that the audio quality was so good, and his microphone was really nice. We were getting his echo off of his own walls in his room, coming back into the mic. And once we figured that out, I was like, okay, I'll allow it. I'll allow it. So the echo cancellation didn't pick that one up, but the audio came out really nicely, having it cranked up that high. Okay, so then we went into our beta testing phase, and the biggest thing I wanted to figure out was how many people can we put on this thing? Because from that WebRTC Hacks blog post, I knew that CPU and bandwidth constraints of a mesh network were going to be a problem. But we figured out you can get about 10 people on a MacBook Air if you don't really do anything else on it. And if you're going to a MacBook Pro or a desktop, you can get 12 to 15. The limiting factor is really the CPU and not that bit rate. And then I had one person tell me that really nerdy piece of feedback that I loved, which was that it runs 10 degrees cooler than a peer in. So I'm just going to shorten that to cooler than a peer in. And then this other one, one user, this was during the alpha, so I was paying attention to every single line of logging traffic. I talked to him, I was like, hey, I noticed you've been in a meeting for like 3 days. Are you doing something, are you using this as like a cat video to check on your pets while you're at work or something? And he was like, oh man, I had no idea. I just left the tab open, I didn't notice. Okay. All right. So that was my run through of how we optimized for distributed teams. This is my email address at MeetSpace. If you have any questions for me, we are going to post these slides as well, so you can get everything there. And we just launched recently. That is a coupon for all of you here if you want to try it out. There's a free trial and everything, but if you sign up, I'll give you a little discount there. So thank you.
Yeah, the free discount works. I actually took advantage of it the other day. We have time for a couple questions. I just ask if you can come up to the microphone so everyone can hear. Any questions now?
I'll be in the break. I'll be stuffing burgers into my face, and if you can catch me between burgers, I can always answer something then as well.
Sorry, I haven't programmed RTC, but when you talk about the bandwidth, is it both up and down, or is that combined?
That was both up and down, because for each edge, you're going to be sending that amount to the other person, and they're going to be sending that back to you. So for 12 people, for example, that's going to come out to 4 megabits up and down. So we wanted to keep that inside what you would expect to have on a company Wi-Fi, on a co-working space Wi-Fi. It kind of pushes the limits to have a big meeting out of a cafe. But usually people come inside the 4 megabits, and it ends up being the CPU that's the limiting factor. So I know we had at a previous WebRTC meetup, we talked about VP9 being really awesome. But when I saw that its CPU went up by 15%, I was kind of sad. So I'm hoping to leverage, hopefully, H.264 when it gets better adoption to bring the CPU down a bit. Sorry?
You mind coming up to the microphone, please?
Is this limited to laptops or desktops? Mobile is not an option?
Yeah, it's not on mobile. It's browser only.
Okay.
It does happen to work just by chance on Android Chrome because it supports it. But especially if you're on one of those new Samsung Galaxies that light on fire, I would not recommend it.
So on Android, did you do the container or Cordova?
Oh, no, it just happens to work in the Chrome browser on Android.
But because on the Chrome browser, it drops the audio when the screen goes dark.
Yeah, no, we don't officially support mobile.
Okay.
Sometimes I just use random devices in my house as extra test machines for fun.
Yeah, because I was trying the Chrome browser on Android.
Yeah, you really have to do
audio,
a mobile solution for something like that.
The screen turns dark and it goes down.
Yeah. The question was, did I measure the performance on the Android device? No, I didn't really pay much attention. I mean, I could do a couple and it was okay, but I don't have any numbers for that. It's not a targeted platform because the teams I surveyed, they take their calls on their laptops, software people for now, so.
Hi, good evening. Thanks for the talk. So my question is regarding, I'm a developer who's starting a project that has to do with WebRTC for the first time. And so how would you maybe give advice to people who are looking at solutions like TalkBox versus kind of a native implementation, since you've recently obviously built a company around this? Yeah.
So when I first started out with it, there were a good couple of weeks where I really just had to put my head down, read sites like WebRTC Hacks. There's also Muaz Khan's blog is good. And then I spent a lot of time on the spec sites, like literally reading through the specs for these things. And you're going to have to learn a lot if you're going to implement it yourself, but you will have a better understanding for sure. So I think what you're going to have to do is make a subjective decision as a developer and figure out if you can spend the time to learn this stuff. Or if you should grab something off the shelf because it's not the core. So I guess the biggest compromises would be having this level of direct control and also with the orchestration. So I have, one of the neat things we do is we have the mute button on spacebar, and that goes through a WebSocket and broadcasts to everybody else. And we're able to do some pretty cool stuff like integrating some of our own customizations on top of the WebRTC solution. So if you just need a face-to-face because what you're really building is a customer support app, don't build it yourself, right? If you're building a business that's based on video conferencing, I really shouldn't have taken anything off the shelf. So, yeah. Am I still good?
Yeah. Why don't we stop it? We'll have to let Ying talk. But when we do here, then Ian can go, and then we'll move on. I will say, if we have time, we're going to do more Q&A at the end and more discussion. So
Yeah,
there's-
and
there's plenty of time to talk.
I'm not gonna run away, and that is my email address, and it makes my watch vibrate because I'm a huge nerd. So if you email me anything, I will get back to you about any questions you have, and we'll post the slides too. So
Why don't you go ahead?
Yeah, just two quick questions, hopefully. First one is, the signaling that you guys are doing, are you using a turn server to get past NAT traversal issues?
yep, yeah, we have stun and turn servers
And-
around the globe.
I've seen AMI instances of people that claim like open source solutions for a turn server. Are you guys using an open source solution?
Yeah, we're using Coturn.
Okay, cool.
Yep.
And second question was around the mesh network. So it was my impression that WebRTC does support one person hosting all the streams and splicing it together. But to confirm what you just explained is every single connection, everybody hosts everybody else. So the four-person phone call that you had, everybody had connections with 3 other people. Is that right?
Yeah, that's right.
Okay.
Yep, it was all individual connections. So that means that somebody can drop for you, but not for me. So sometimes we get these net split style situations there. And so one of the things that we're going to be working towards in the future is better connectivity indication for everybody. So letting them know that somebody's partially disconnected and being able to target somebody in particular. So right now I'm still looking at all the logs, and people will, like a user will come and say, oh, we had a bumpy meeting, and I can look through the logs and I can say something simple like, oh, like Chad had a lot of packet loss at 1:35, and then we find out that Chad was at a coffee shop, you know. But I'm hoping to bring that into the UI itself. But all the data's there. You can tell when somebody's got packet loss. You can tell from which perspective the packet loss occurred, if I was losing from you or you were losing from me, or both. So it's all there.
Thanks.
All right, last one.
So you mentioned that you're waiting for H.264 until the support for it is better. So I'm wondering whether you have tested H.264 and whether you see any problem.
I haven't tested it, and this is probably a better question for Chad. But the one thing that I do know is that there are a lot of cameras out there that will encode the stream to H.264 with a hardware chip,
Right.
and that would save a lot for us. That would allow me to really crank the limit up and maybe even raise the frame rate. So I would like to be able to use that. But as far as I know, H.264 hasn't landed publicly in Chrome yet without a flag. But he would know better than me.
I think as of 52, it is in there without a flag.
It's in there. All right. I've had my head down. But yeah, no, that'll be really great.
All right.
That'll be really great.
All right. Thank you, Nick.